Alright, so you should have just carried out a practical that involved heating some distilled water, recording the temperature and recording the pH at that particular temperature. The two things you should have noticed is, number one, that the pH on the meter decreased, and the second thing would be that the universal indicator, the colour, stayed the same. So if it started off orange, it ended the same intensity of orange. So what we're going to try and do now is just try and explain why we saw what we saw. So the first thing we need to look at is what happens when we heat water. So if we take a water molecule, if we heat it strongly, what we can do is we can dissociate it, and we can make it form these two ions. Now whilst that's happening, we can also combine these two to make the water, so we've got a reversible reaction. Excuse me. Now, this overall reaction is, not overall reaction, but the forward reaction is endothermic, which means that when we put energy into the system, Le Chatelier's principle will state that it will favour the endothermic direction. So we will make more of these ions. Now the role of the pH meter is to pick up the number of these H pluses. It actually just ignores these OHs. So by increasing the temperature, we increase the concentration of H plus ions, and therefore we decrease the pH value. Now if we decrease the pH value, then we would normally expect to see a colour change, and in this case we didn't. And the reason for that is that for every water molecule that we dissociate, we produce one H plus and one OH minus. So that means that we've got 1 to 1, so the overall solution will always remain neutral and the colour will not change.